Hey everyone, today we're gonna be doing a Leetcode question which is IPO. So they are saying like suppose Leetcode is starting to launch their IPO soon, and in order to sell its share in very good price, Leetcode decided to work on some project as quickly as possible and with minimum capital they have. So they are saying like Leetcode would like to work on some project to increase its capital before launching its IPO. They are saying like since resources are limited, means people working inside Leetcode is very limited. They can finish only K most projects. So at most they can finish K distinct project before launching the IPO. Now they are saying help the Leetcode to design best way to maximize the total capital after like finishing the Kth project. So they are saying we need to make some program here so that Leetcode can finish the kth most projects with the maximum capital. So they are saying you are given n projects where ith index represent the ith project with their like profits and the capital required to need that project to work on that project. Okay, so they are saying initially we have zero like W capital. Suppose here like for first company they are saying initially they have zero capital for that. So similarly we have given the profit array, we are given the capital array. So capital array means what is the amount required to start that project. How, and the profit array means how much amount they will get after finishing that project. Yeah, they also given the initial capital, like this is the starting capital they have to start a project. They're saying like when you finish a project, the profit inside it will be like contributed toward your total capitals, means it will be added to your W capital. They're saying you can pick at most K distinct project and you need to maximize your capital, final capital. Okay. They're saying like answer will be fitted to 32-bit integer, so that's fine. So if I say some example here, K is given 2, profit is given 0, initial capital it's 0, profit array like this, capital array like this. Let's see the constant first. So they are saying total number of projects like which they can work on can go from 1 to 10 to the power 5. The initial amount which the company have can go from 0 to 10 to the power 9. Number of profit array or the capital array will be fixed of n size, which is 10 to the power 5. So both the array, capital array and the profit array will be of same size, and the element inside it, like the amount, how much profit they gain or how much capital required to finish a task, can go from 10 to power like 0 to 10 to power 6 for the profit per project, and the capital required to work on a project can go from 0 to 10 to power 9. So let's see some example like how we can do this one with some coded example. So let me open our code editor. Sorry, the manager. Yeah. So let's take the first example. Uh, we have like kth project as 2. I can finish at most k project. Initial amount I have 0. And if this I say profit array. Profit array I have 1, 2 and 3. So this is the profit will be gained after doing this indexed project. Similarly, I have capital array, means this is the amount required to work on some project. Okay, they are saying like they need to pick up uh, the projects which will be contributing towards the maximum profit by doing the kth project. Okay, so if I say for this example, also they are saying like you are required to like you can start your project with this particular amount, like you will have to start your project with the amount you have as an initial capital. So suppose the initial capital given to us is 0, so we cannot start the project having budget as 1, like these two cases. So if I say these, this and this, these are the three different projects. Okay, these are the projects with the capital required to work on this project is 1 and the capital or the profit they will gain is 3. So if I say very brute force approach, what they are trying to say, they are saying, okay, you can pick at most two projects. So if I say I can start from zeroth amount project, so I can pick only this one. After doing this one, my total profit will be like gained with one. So my W will become one over here. Okay. Now with the initial profit, whatever project I'm doing, it will be contributing toward my final capital. So initially it was zero. By doing this capital zero project, I gain 1 rupees, something. So it will be added to our capital. Now I can do any project which is having capital with one. So I can do this one or this one. But if you say I'm allowed to do only two projects, if I have done this one, I gain one capital over here. My now project will remain is one. So I have two projects. After doing this one, I can do only one project after this. Either I can choose this one, I can choose this one. I need to choose the maximum one because both are having same cost required to work on a project. But this will give me two profit, this will give me three profit. So I need to like take this one. So if I say the very brute force approach, what I can say, okay, let's have the capital array. So something I have like, I might have some Hashmap. So for now, for the namesake like of showing you what will be running behind the scene. So suppose I have this as a Hashmap. Okay, here I have the, I'll say like these are my capital. Okay, now I will be storing all these capital as a maximum amount first. So for storing maximum, I might be having some heaps because either I can like store and I can do the sorting for all, uh, or I can do like I can have a heap data structure which will be either storing the minimum on the top or the maximum on the top. So for now, for storing this all, I can have a maximum heap. So for this particular amount of capital, I can have this. So I might be having a heap over here. For this, I can have what? I have one. So for this, I have one capital. For this one, I can have two types of capital. Like I have three and two. So what I'm trying to say, for each of this capital, I can get at least this many profits. So I need to choose the maximum profit from here. If I say, okay, this is one example, what I can say, okay, just iterate over your k times, like how many project you can do, iterate till that. Now you can do one thing. You can start with your initial amount. You can pick at least this one. So I can say, okay, I'll do something like while I'll say I might have like one loop like while we have our this project remaining is greater than zero. Okay, or it will be going something on. Also, I might have be checking like how many like projects I have remained over here. So I might have another condition like okay, length of something. Let me shift this one bit. Okay, so I might have like length of this hash map. This map should be greater than zero. So I might have these two condition to work on it. So what I will be doing like I will be like iterating from zero. I will be including. So I'll say okay for I. So I might have another condition like for I, it will range from where it will go from W plus one. I need to include Wth part. So what I will be doing like I will be taking okay initial capital. I will be checking okay with the initial capital what all I can have. So for now initial capital was this alone. Like with this initial capital I can do this project. And in this project like for this capital I have only one project. So I can take this one. I can remove this one. Now I have my initial capital now become 1. I can include all the project with having the capital as 1. So I can again iterate from 0 to our W plus 1, or you can say till W. I need to complete all the project. So I will be checking okay with this particular amount. Suppose this was not 1 and this was not 2. So suppose this was given 1 and this was 2. Okay. I might have my initial capital as 2. This was W. Now, in order to check, I need to iterate over all this. So I will be starting from 0 I will be going from 0, 1 and 2. I will be checking, okay, is your first element is greater? Is your first element is greater? So what I will be doing, like I will be iterating over these keys, and in the values I have my maximum heap. So for each heap, I can get this element with O1 and I can iterate this with how many times? So this for iterating this, I'm iterating till W, okay, and I will be doing it for k many times. So my time complexity will go from uh, k times into W time. But if you see constant, they are given like k can go from 10 to the power 5, like 1 to 10 to the power 5, and w can go from 1 to 10 to the power 9. So in this case, our time complexity is very high. It is 10 to the power 14, which is very, very high. We cannot do in a single loop as well. So this approach didn't work, but it is what is trying to say, like I need to have the maximum profit one from this particular capital project. So if I have two capital project, I have this capital 111. So for one capital I have two projects, one is this one, one is this one, so I need to pick up the maximum one. So what I can do, I can take help of a two heap. Like see, we are required to use heap data structure because I might need the maximum one to pick first. So what I can say, okay, instead of one I can have two heap. Okay, I can have two heap. Initially I will be having what, uh, I will be having one min heap, and one is max heap. So what I will be doing, I will be taking the minimum capital one. So I need to do the minimum capital task first because this can be done uh, like very fastly. Like see, I have one capital, I can do the zeros first. If I have the zeroth amount from here, zero capital task, I can do it. Why I'll do the first one capital, two, three capital task if I have only zero? So I will take the minimum capital task first and I'll try to maximize my profit. So I will be doing greedy approach here with the heap data structure. So what I will be doing, I will be storing each pairs like this. So I might have like elements as 0, 1. So I have this capital. So this capital and profit array I can club. So I have 0, 1, 1, 2. So I have now 0, 1, 1, 2 and 1, 3. So it is the capital required and it is the profit gain. Now each time I can pick one element from this min heap with the minimum capital. So initially I'll pick this one. Another time I can pick these two. Okay, any of them I can pick. So what I will be doing, like I will be checking if I have this one, if I have the capital, my w is less than equals to this, so I can pick up. Initially my 0 is like my w given is 0. I cannot pick these two, but I can pick this one. So I'll pick and remove this one from here. I'll remove this one. I'll say, okay, remove from here and just append your what? Your profit over here. So I can have one profit from here. So I have one profit from here. My W will become 1 because I have gained one profit. So this profit will go added to be over here, and I don't have anything. So I can remove this from here and I can add to the profit part. Okay. If I have only one part, I can add to the profit part for the first go. Okay, so I'll remove it from here as well. Now I have added to our capital gain this task. Now every time I'll say, okay, my W become what? 1. I need to include all the element having initial capital less than equals to W. This time I have these too many capitals. I have these two. I'll just push over here. Like I can do this two tasks, but I can do the maximum task, like maximum profit task first. So I'll do what? I'll just simply pop this from here and append the profit over here. I'll pop this one and append the profit over here because it is the minimum. Any of them I can pick. It is a main heap. So it will be giving me these two because its capital required to work on a project is 1 and I have my current profit, current capital as 1. So I can take these many two tasks. Suppose something was there like 2, 3 and 4, 5 something. It will be like not pick because our capital, like current capital, is less than the given capital. So okay, I can pick these two. I can pick these two. I can append the profit over here alone because we are just required the final profit. Now from this max heap, I will be like popping out this element. Okay, the maximum one. I can include it to my gain. So I will remove over here. Now you're saying like how we decide to take this one, not this one. Or what if like I have some task 2 or 3 having profit 0 or profit 1. Is it good to do this one or this one? So yeah, we will be doing both. Like suppose I have one more element with 2 and 1 profit, 3 with 0 profit. I will be like, I have added the 4 as a profit. I will include this one and this one in my heap. So I'll pop this one. I'll include the profit over here. I'll pop this one and include the profit over here. Now I'll take the maximum element from max heap because it is max heap. It will give me the maximum profit one. So we are not like bounded with which task I am taking. I am just taking what profit I'll have at last. So this time it will pop the 2 from here. Now it will pop how many element? Only the k element. If our k goes greater than the project task, or some, you can say if my this heap becomes 0 in any go, like while popping it from here and we haven't added something here and it is 0, it means I don't have any task to be done and it should be terminated from here. So this will take like we will be iterating over the n projects, and each time I will be doing a pop here and pop from here and push from here. Okay, so each time I will be doing 2 operations. So it will take like log n operations. So I will be like iterating from where? I will be iterating from k into 2 times log of n. So it means like k log n, which is optimized from k into n, or you can say k into w, which is worst. So let me show you with code how we gonna be doing this one. So yeah, let me write this code first. So let me zoom this one. So initially I have W, so at last I need to return W, which is a final capital. I will be having 2 heaps, so I will be having max heap and min heap. So min heap I need to include all the elements, so I will be doing in place. So I have this. I will be like taking my capital and profit array from like for capital and profit in zip. I can use zip function to iterate both the profits and the capital array in the same go. So I'll take okay for profit or capital comma profit because I need capital to be taken first, which will be taking first capital and profit. Okay, profits. Now if you say in a heap I can have only one like one element which will be compared. But if you see like we are creating a tuple over here. So suppose if something is like 1 comma 2 or 1 comma 1 and 1 comma 2, okay, I have this element, both have like first element is 1, so it will like take the difference of it, like I have 1 comma 1 and 1 comma 2. Also I have something like 0 comma 2. Okay, so if I say for the main heap, it will be picking up this first, then this, then this, because I if I say for the heap, whatever element is there and how many times or like how many element it might have, like it might have 3 4 indexes, something like this, something. It will take the first element first. If the first element get the same like here, like 1 1 is common, then it will go to the second element. So by default, like it take the first element. So let's create this one. We have created the heap, but I need to do the heapify this one because that was a normal array. So I'll say okay, heap dot heapify. So heapify will heapify the mini heap. Now I need to iterate till what? I need to iterate for I in range k. Like I need to do at least at max k tasks. Okay. But if in some point our k goes to suppose I don't left like I don't have any element in my max heap, then so I need to like terminate my loop. So I'll break it from here. Every time like I will be including some profit from this to my like from the max heap. So I'll be like popping out the maximum element from max heap. So I'll say okay, uh, the heap pop, heap pop, heap dot heap pop. Okay, so I will be popping out the maximum element from this max heap and I will be appending it to my total capital. Now the main logic goes here, like how many elements we have in a main heap. So I'll say, okay, main heap and whatever element present in the main heap having the this shows like if I say main heap 0 means the first element, the first smallest element, and I need to check the capital. So whatever capital is less than equals to W, I can include all of them. So I might have capital and profit from our heap. So I'll say, okay, heap q dot heap pop. So I will be taking out that element from main heap. Okay. Now I have our this this will give me like this particular tuple. So I have the capital and profit from here. I just need to put the capital to our max heap. So I'll say, okay, heap q dot heap push to the max heap the profit we have. Now if you say min heap, I can do like by default every heap is a min heap in a Python. We don't have any max heap. So what I can do, I can reverse its polarity. So I can reverse the polarity means the maximum will become the minimum. If I say it is minus, like minus 10 is minimum when comparing to 0. Suppose I have two elements, 1, 2 and 3. If I wanted to implement the max heap, but I don't have, so what I can say, okay, I can reverse its polarity minus 1, minus 2 and minus 3. So when I pop this from min heap, it will give me what? Minus 3 first because the minus is the minimum element because I have reversed the polarity. For each element, I will be doing the same. When I will be popping this one, again I will like multiply it by the negative. So it will change its polarity again. So if I pop it 1, it will be minus 3, but if I say okay, and 2 with minus 3 again. So it will become what? Plus 3. So I will be like pushing the minimum element uh, from here with the negative sign, and I will be taking the maximum element or the minimum element you can say from here, and I will be appending the minimum side. So it will like append like reverse the polarity. So let me compile this code. Let me see if it is running fine or not. So it is saying like error module heap q has no attribute heap up. Okay, I forgot the h. So let me compile it again. Heap, okay, heap up. Um, so it is giving me main heap is not defined because we have given the capital H. So yeah, very small mistakes. So again, we compile this code and stem this work and we'll submit this code. Let's see whether it is running fine or not. So yeah, that's work fine and it's bit optimized and yeah, that's all for today's lecture. Thanks for watching.